Alrighty, guys. We are in section 9.3, the law of sines. It's on page 262 of your student journal. What is essential question? What is the law of sines? Well, we're just going to jump right to it, and I'll show you how to use it. So I'm going to split this up into two videos because just to make it smaller, so you have two digestible videos. And this one is going to focus on the area formula. So the area of any triangle is given by 1/2 the product of the lengths of two sides times the sine of their included angle. For triangle ABC shown, there are three ways to calculate the area. So one thing I would say is in terms of vocab is included. Like, what does included mean in this context, right? So let's try and look at the formula and see if we can come up with a definition for included. What does that mean, right? Because the easiest, most obvious context I can think of is like when they sell a toy and batteries aren't included. That means you don't get the batteries, right? But in this case, you're like, oh, well, what would we get? What would we get? What is there to get in this problem? So let's look. And again, it's when it says included, it's referring to an angle. So let's see what that means. Area equals 1/2 BC, and you'll notice that they're lowercase, so it's referring to the side lengths. BC is referring to the side lengths, times sine of A, which is in this corner, so it's referring to an angle. So 1/2 side length of B times side length of C times sine of A. So what does included mean in this context? We have B, we have C, we have angle A. What is a word we could replace included with? Okay, so I just wanted to give you guys a few seconds to think about an appropriate word before I just told you. But using this context, well, let's go see something else. Then let's go look at these and see if you haven't come up with one, then of course I'll tell you. But let's see if we can come up with. So let's use a different color. So we have differentiation. AC. So AC, and the included angle for AC is this one. And let's go to the last one. We have A, we've got B, A, B, and then the included angle is C. So in this context, then the included angle is basically just means the angle between the two sides that are given, right? So this angle is between the two sides, this angle is between these two sides, and angle A is between sides B and C. Let's go back to blue so it's nicer on the eyes. Okay, so area of a triangle, 1/2, two sides, the included angle or the angle in between those two sides. So let's see what that looks like. We'll come back to this. So we'll also show you this, but that's way easy, so we're just gonna let the calculator do the work. Find the area of the triangle. Round your answers to the nearest tenth. So we want area equals 1, let's say 0.5, side times sine of included angle. So what two sides do we have? We have side EC, which is 14, or 1/2 times 14. What's the other side we have? We have 9. And then sine of included angle. The angle in between these two sides is 79. Sine 79. So I'll show you guys how I'll do it using Google's calculator. Of course, you're welcome to use the same. Or if you have a scientific calculator or a graphing calculator at home, then you can use that. We're just going to pop this in pretty much exactly. So, fractions, well, 1/2 times 14 times 9. That 1/2 times 14 times 9 times sine 79. So Google understands that parentheses means we're just going to be multiplying them, right? So let's do it. Okay, so we have an area of negative 27. Does that make any kind of sense to have a negative area? No, it's impossible, right? Like it's not a black hole of space. It has an area. So what went wrong? 1/2. That's good. Let's look at our 14. Okay, that's okay too. 9. That's okay. Sine 79. Ah, it says sine 79 radians, but the units are not in radians. What unit is this? It's degrees. So when you do this, whether in your calculator or in Google's calculator, make sure you type in degrees, or if you're using a handheld calculator, make sure somewhere on the face of it should say uh, DEG for degrees, and not rad for radians. And so, boom, here we go. 61 point, it tells us to round to the nearest tenth. Round your answer to the nearest tenth. So there's our answer. 61.8 units squared. We don't know what the units are. We don't know if it's inches, feet. We just say unit squared. So what that will look like is 61, or A equals 61 to the nearest tenth, it said. 84, yeah. 84 is units square. Or you can say square units, whatever. And this is approximately because it's not exactly 61.8. Okay, so that's one demonstration on how to use the area formula. We could do it again for sure. So again, I have side 1/2 times side times the sine of the included angle. So we got side, and sine of 24. Sorry for all that noise. I don't know what the neighbors are doing. So we got A equals 1/2 times 19 times 22 times sine 24. So we're going to put it in exactly like that. 1/2, 19, 22, sine of 24. 1/2, 19, 22, sine of 24 degrees. Again, being sure that your calculator is working in degrees and not radians. And if I round to the nearest tenth, well, that's the nearest tenth, and 0 rounds it down to 0. So this will be 85 square units. If you just want to write unit square, like I did over here, that's totally cool too. I'm just giving you another option. Okay, so that's that. And let's go back to the previous problems. So we skipped it entirely. Use a calculator to find the trig ratio. Round your answer. It's literally just typing it into your. Well, round your answer to 4 decimal places. Okay, so sine 225. Sine 225 degrees. Negative 0.7071. 4 decimal places, so 4 places after the decimal. The 0 rounds the 1 down, or keeps it at 1, I mean. So negative 0.7071. And they include these problems basically to make sure that you know how to use your calculator, so that when you're doing this, you're typing it in correctly and you're not doing something like putting in radians or something like that. Cosine 111. So 4 decimal places, 358. Oh, the 6 makes that go to a 4, so negative 0.3584. And then tan 96. You get the idea. Boom, there it is. 1, 2, 3, 4 places, but the 6 rounds it up to a 4. So negative 9.5144. This is all, number 1 through 3 is just calculator work. There's not too much thinking involved, if any. In exercises 6 through 8, solve the triangle round decimal answers to the nearest tenth. So what this means is, solve means find everything that we don't know, which includes all sides and angles. And so for this, we have the law of sines. So the law of sines can be written in either of the following forms for triangle ABC with sides of length A, B, and C. So it basically just shows a relationship of proportionality. So sine of angle A over A is equal to, or the same thing as, sine B over B, and then sine of angle C over C. And then it could also be framed the other way around. So take the sides over there. Take each side over the sine value of the corresponding angle. So don't forget that in a triangle, the corresponding angle is the one that it basically has a relationship with, right? So across from angle A is side A, because if angle A gets wider, then that has a direct relationship with side length A. So again, if I increase this angle to make it bigger, then this will have to stretch out, then A is getting bigger. If I take angle C and I make it smaller, so then instead of going like this, it would go like this maybe, then side C directly across from angle C will also get shorter. So there's that. Okay, so in exercise 6 through 8, solve the triangle, round decimal length is the nearest tenth. Okay, so first off, we have two angles in a triangle, and what do all triangles, or the interior angles of triangles add up to? It's 180. So I have 50 plus 30. So this one, 50 plus 30 is 80. 180, then this one needs to be 100 degrees, right? And if you needed to show your math, then you could say, 180 minus 50 minus 30 equals 100. And then let's find the two sides. So again, it doesn't matter how you do it. It says it can be written in either of the following forms. So sine over side. Or you could say side over sine. Again, it's just a matter of preference, so I'll show you either way. The one thing to keep in mind, though, is that we are keeping the sides and the angles in an appropriate relationship. So if you say a side over a sine of an angle, it has to be the angle directly across from it. So here I have 22. So I'll go with side over sine. And so which angle is directly across from 22? Pause. Give you guys a chance to think about it. Directly across from 22 is this one right here, 30. So I'll go ahead and take sine 30. And we have to find these both these other sides, but we don't know them. So this is angle B and side B. So we have to find A. And we have to also find C. So across from A is angle A, which is 50. And let's just do this for A real quick. So, and we'll do C last. We could just cross multiply. So I have A times sine, I'm just going to type it out. A times sine 30 equals 22 times sine 50. And to get A by itself, then I have to divide by both sides by sine 30. So let's do this right here, divide both sides. Sine 30. Divide this side by sine 30. So we'll have A is equal to 22 sine 50, 22 times sine 50, divided by sine 30. So again, just use a calculator. 22 times sine 50 degrees divided by sine 30 degrees. So I've got 22 times sine 50. And I'm doing this just so we look like, oh, everything's happening in the order that we wanted to. We're not like misoperating anything. And it checks out 22 times sine 50 degrees, 22 times sine 50 degrees. After I multiply it, then I go ahead and divide it by sine 30. I get 33.7. It says round decimal answers to the nearest tenth, so the 0 doesn't do anything to 7. So I have 33.7. And then for C, we are looking right here, and across from C, side C rather, is angle C. So I'm going to be working with sine 100. And if I set it up, we're going to do the same dealio, but I'll do it in red so you see. So I'm going to cross multiply again. So we can ignore this since we've already done it. So we can just scribble all this out. We did it already. So we're going to cross 22 over sine 30 equals C over sine 100. So we can cross multiply here as well. 22 times sine 100 equals C times sine 30. Type it out for you. 22 sine 100 times sine 100 equals C times sine 30. And we're going to do the same thing where we divide both sides by sine 30 to get C by itself. So 22 sine 100 divided by sine 30, 43.3. The 3, doesn't do anything to this. So we have 43.3. And that's it. So I'm going to clear this all. As of this moment, like, if you get area and how to solve a triangle, then you're good. Like, you don't have to watch the rest, but if you're into another example, let's see, I got two sides here, I got two sides and an angle. Okay, so let's just go for it. And I'm gonna draw the relationships just so it's like kind of obvious. So these two are related, these two are, and then these two are, because they're just across from each other. Right here, angle A, so this would be side A. Angle C, so this would be side C. And angle B, so this would be side B, right across from it. So I'll set up using we just did sides on top, so we'll do sines now on top. So if I said sine 82 over 25 equals, what do I got? 16. And then sine of, oh, I don't know the angle. So if I don't know it, you could call it x if you want, or you could say, oh, it's sine b, right? So we are going to go ahead and cross multiply again. So 16 sine 82, 16 times sine 82. So much faster if I just type it. 16 sine 82 times sine 82 equals 25 times sine b. And so I'm going to divide both sides by 25. Divide by 25. And then, let's see, 16 sine 82. 16 sine 82 divided by 25. And I've got 0.63377. So I'm actually just going to want to copy and paste this. We want to be as accurate as possible. And this is not the answer yet. So equals sine b. So we know the sine ratio, but we don't know the angle. And so this is some more calculator work. And this is a skill you learned, or you should have at least gone over last year, but if not, no biggie. So in your calculator, we have, let's see, do we have it here? No. but let's see if it'll do it anyways. Inverse sine. Will you do it? Nope. Okay. Oh, sorry. Nope. Okay. Let's do trig. No. Well, what'll it turn up? Yeah. Trig calculator? No. Inverse trig. Oh, arc. That's what it's called. So basically, if you put in, you'll use this calculator, and it'll. If you have a scientific calculator, it looks like this, or like this. And what you put in, or the input, is the ratio, and then what you get out is the angle in degrees or radians. Depends on the calculator you have to set it. So let's see. I want to plug in this value. Cool, which is 39.328 degrees. It says, oh, sorry, where am I? Oh, here. It says round decimal answers to the nearest tenth, so 39.3 is this angle. Angle B is 39.3. And then we could say 180 minus boom minus these two is that. And then once I know this angle, I can set it up. I mean, I'll do the setup and then I'll leave the calculation for you. We can use any ratio we want, but I'll just use what we started with. Sine 82 over 25. Pretend this is an equal sign because I made that extra long for no reason. Equals sine of angle C, which you can get by taking 180 and subtracting these two numbers and leaving it right there, over side C, which then you'll have to, after you plug this angle in here, you'll cross multiply, and then you'll divide both sides by sine 82, etc., etc. So that's it. That's for area and using the law of sines. If you have any questions, let me know.